Hey there, Mr. Weaver here, and this is Topic 9, Lesson 1, Solving Quadratic Equations by Square Root. After this lesson, you need to be able to identify the zeros of a quadratic, and you need to be able to solve for a variable in quadratic equations using inspection or square roots. You'll know you're successful after this lesson if you can identify the zeros of a parabola by finding where they intersect the x-axis, and if you can solve for the variable by inspection or by square roots. First, before we begin solving our quadratic equations for the zeros, let's remind ourselves what a zero is. So the zeros are the points on a parabola where it crosses the x-axis. They're also called the x-intercepts, roots, or solutions. So here we have a parabola, which is the graph of our quadratic function. There are 2 points on this one where it crosses the x-axis. Those are the zeros. Now, sometimes there will be 2, sometimes there will only be 1 point where it touches, and sometimes it won't touch at all, but here there are 2. So first, as we continue to remind ourselves what zeros are, let's look at some real context and use Desmos to help us figure that out. So Kelly tosses her hat from the roof, 64 feet above the ground. The height of the hat, y, is represented by the equation y equals negative 16x squared plus 64, where x is the time in seconds. How long will it take the hat to hit the ground? So in a second we'll go to Desmos, but we're looking for when it hits the ground. So when we go, we're going to get a parabola that goes up and then comes back down. There's going to be 2 places. We want to know when it's hitting the ground. So let's figure out what those 2 places are, where it's at 0 or the ground. Here in Desmos, I have our function typed in. If we zoom out, we can see our shape goes up pretty tall and then comes back down. In this situation, there's 2 places where our parabola crossed the x-axis, so we have 2 zeros, at negative 2, 0, and at 2, 0. We're going to be using just the x value. So we would say the zeros are when x equals negative 2, and when x equals positive 2. So our zeros were x equals 2 and x equals negative 2. We wanted the time where it's going to hit the ground. If we're thinking about where x is time, only one of those makes sense in this context, and that is when x equals positive 2, because we can't have negative time, so tossing the hat would hit the ground forward in time. So that would be that right dot. So when x equals 2. Now it's your turn. Pause the video. Use Desmos to type in the function. Where are the zeros and how long does it take for the ball to hit the ground? Let's check. You should have found the zeros where x equals negative 0.179 and x equals 1.742. I just used Desmos, typed in our function, and clicked. The positive one is going to be where it hits the ground, so we go forward in time at x equals 1.742. Now that we've reminded ourselves what zeros are, we're going to begin solving for x, or whatever variable it is, in a quadratic equation. The rest of this video goes through method 1 with square roots, but there are 5 different methods. And some of them will work sometimes, some of them will work all the time, some of them are easier than others, but they all work in different cases. The first one that we're going to look at in this lesson is square roots, and this one sometimes works. So we're going to look at the cases where it does, but for your reference, it only sometimes works. We're also going to look at, in future lessons, factoring, which sometimes works, completing the square, which always works, quadratic formula, which always works, and graphing, which always works if you have Desmos. If you don't have Desmos, it's actually pretty difficult. So let's go through and look at our first method, solving by the square roots. So this method is useful if x squared is set equal to a value. So if your equation is just like x squared equals 49, you can kind of just look at it, which is called inspection, and you can figure out what number times itself equals 49. One caution, the number that it's set equal to must be positive. We'll see why when we go through our examples. Another time this is useful is if there is no b term. So if you just had x squared plus 7 equals 56 or something similar, you could easily just subtract that 7 from both sides and you're back to where it's x squared equals a number. But again, that number on the other side of the equal from x squared must be positive. Finally, this method works well when there's a binomial squared. So that binomial, x plus 3 to the second power. Essentially, the binomial in parentheses there works the same as x to the second power. We'll see in the third example. So let's get into how this works. So our first example here, we just have x squared equals a number. So we have x squared equals 25. We can use inspection and just look at this and kind of figure out and test some things out. What number times itself is going to give us 25? You might think, oh, 5. 5 times 5 is 25. And we'll see that will be one of our answers. As this lesson is dealing with square roots, let's take the square root of both sides. So if I do the square root of x squared, I end up with x, and if I do the square root of 25, I end up with 5. Now, be careful. Positive 5 isn't the only number that you can multiply and get 25. You can also multiply negative 5 times negative 5 and get 25. So, when you're taking the square root, you need to remember there's going to be a positive version and a negative version of your answer. We can write this using a symbol that's called plus or minus. So here I wrote x equals plus or minus 5. That plus or minus symbol just shows that the answer is both the positive and negative version of that number. So I can see here that it's x is positive 5 and negative 5. And that symbol can help us write it a little quicker. Now it's your turn. Pause the video. What value or values of x will make this equation true? Let's check. You should have got x is equal to plus or minus 9. So if we start with our equation and take the square root of both sides, you get x equals positive 9 and x equals negative 9. So plus or minus 9. Let's look at another example that looks slightly more complicated. So we have 2x squared minus 5 equals 13. In this case, there is no b term. So that term with just the x is missing. Because there's no b term, we can use the square root method to solve. All we need to do is just get x squared by itself, and then we can take the square root, just like we did in the previous example. So we're going to go through and solve for x squared in pretty much the same way if it was just an x. So the first thing, we can add 5 to both sides, and I'd be left with 2x squared equals 18. Then I could divide by 2, and I'm left with just my x squared equals 9. Now I can take the square root to get x by itself, and I would end up with plus or minus 3. So I solved it the same way as if it was just a regular single x, and then at the end we took a square root. Now it's your turn again. Pause the video. What values of x make this equation true? Let's check. You should have found x is equal to plus or minus 2. Here's how we get that. If we take our original equation and begin solving for x squared, we add 3 to both sides, then divide by 4. Then we're left with our x squared by itself equals 4. So last step, take the square root. X is equal to plus or minus 2. Here we have our final example where we have a binomial squared equals a number. So x minus 6 to the second power equals 16. That x minus 6 to the second power is showing that we have a binomial square, which is a good time to use the square root method. Even if there was something added at the end, so like if it was x minus 6 squared plus 4, we could still use this method. We just would have to get that binomial square by itself. Kind of like if it was x squared, we would get that binomial square by itself. Okay, so we're going to solve for that binomial as if we were solving for x. So if this was just x squared, we would take the square root of both sides. We're going to do the same with a binomial square. When we do that, you end up with what was inside the parentheses equals the plus or minus value. So I have x minus 6 equals plus or minus 4. Now, here's where this method is a little more complicated. We're actually going to need to think of that plus or minus as positive 4 and negative 4, since it's equal to two things. So what you're going to need to do is split it. So we're going to have to do x minus 6 equals positive 4, and then solve for x. And then later we'll do x minus 6 equals negative 4, and solve for x. So here, first we'll do the positive. To solve for x, I would just add 6 to both sides and figure out that x equals 10. So that's one of my answers. But x minus 6 also equaled negative 4. So you're still going to solve it the same way both times. So add 6 to both sides. And we find that x equals 2. So those two values are what you could plug in for x and get your answer. If you did 10 minus 6, you get 4. 4 to the second power is 16. If you plug in 2, 2 minus 6 is negative 4. Negative 4 to the second power is 16. So both of those things work. Just remember, when you take the square root, you're going to end up with a positive and negative answer. Split them apart, solve for both. So now it's your turn. Pause the video. What values of x make this equation true? Let's check. You should have found x equals 9 and x equals negative 1. Here's how we get that. If we start with our equation and take the square root of both sides, we end up with x minus 4 equals plus or minus 5. And then setting it equal to the positive, so x minus 4 equals 5. We just add 4 to both sides. We get our x equals 9. And x minus 4 equals negative 5. So adding 4 to both sides would be x equals negative 1. So in this lesson, we quickly reviewed zeros, which is the place or places where a parabola crosses the x-axis. They're also called roots or solutions. So when we're solving a quadratic equation, the zeros are the solutions, or the values of x when y equals 0. There are 5 ways you can solve a quadratic, and each of them has a time when they're easier to use than the others. So you'll have to kind of figure out which to use. We can solve by inspection, or square roots, factoring, completing the square, quadratic formula, and graphing. And we will look at all of those in upcoming lessons. So here we looked at a first method of inspection, or taking the square root. This method only works when there is no b term. So even when it was set as x squared equals a number, there's still no b term. And if you find that's the case, then the square root method is pretty simple. You solve to get x squared by itself until you get x squared equals a number, or the parentheses squared equals a number, and then just take the square root of both sides. When solving for x in this and in future methods, don't forget you need to make sure to remember to get both the positive and the negative values after taking the square root, or you're going to only end up with one of your two answers, and missing an answer makes it wrong. So after this lesson, do you now know how to identify the zeros of a parabola? And do you know how to solve for the variable by inspection and or taking square roots? If you're not sure about these things, go back and look at the different examples to see how to solve each format. And that's the end of lesson 1 on solving quadratic equations by square root or inspection.